Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 6, Linear Systems, How Many Solutions. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so when we have linear systems, which is when we have a graph of two lines, the solution to the system is a point of intersection. So there are three cases that can look like for linear systems. When they have no solution, that means they have no point of intersection or 0 points of intersection, and that means the lines never cross, so they look something like this. You might have seen this in school called parallel lines. The next case is one solution. So when we have two lines that intersect, they cross at one point. We call those intersecting lines. And the final case is infinitely many solutions. When you have one line directly on top of itself, it just forms one line. They're the exact same line. So those two lines exist in the same spot. They coincide with one another. So we call those coincident lines. You don't really need to know these words for these types of questions on the SAT, but I feel this vocabulary is pretty important, and I'm going to be using these terms kind of interchangeably throughout the video. So if you hear me say no solution or parallel lines, I'm talking about the same thing. Likewise, if I say intersecting lines, I'm talking about the one solution case. Great. And just as a quick refresher, slope-intercept form of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Feels kind of silly to go over this, but this actually isn't on the reference sheet, so please make sure you know this like the back of your hand. So probably the most important slide in the entire video. Please take the time to jot this down. For no solution, which we just talked about, looks like this. We know that the two lines have to have the same slope and different y-intercepts. For one solution, which looks like this, we know that these guys have to have different slopes. We can't say anything about the y-intercepts. We would need more information. They could have different y-intercepts, or they could have the same y-intercept. We don't know for sure. All we know is that they have different slopes. If lines have different slopes, they cross. And for the infinitely many solutions case, which looks like this, we know that they have the same slope and the same y-intercept. So please, please, please take a second to jot this down. Understanding and knowing this table, like the back of your hand, is crucial to a lot of digital SAT math questions. Okay, let's do some examples now. So these aren't really problems. This is kind of meant to show you the ropes. So we're going to pick out, we want to know how many solutions this system has. So we're going to pick out the slopes. We see that the slopes are both 5, so that means they're equal. So these guys have the same slope. Now we're going to pick out the y-intercepts, the b. And remember, if there's a negative sign there, that should include that. So I'm going to circle the sign as well. So this guy, both of these have a y-intercept of 4. 4 is equal to 4. So these guys have the same y-intercepts. If I now go and look at my table for same slope, same y-intercepts, which I should know down pat like the back of my hand, this system has infinitely many solutions. Let's do another one. Okay, so let's say for this question, a and b are constants, and I tell you that it has no solution, and the question wants you to figure out what you can say about a and b. So the very first thing is we're going to write down on our scratch paper what it says about no solution. So we know that no solution has the same slopes and different y-intercepts. So we're going to circle the slopes, and they're the same, so we're going to use an equal sign. A is equal to 2. And then for different y-intercepts, the y-intercepts are b and 3. But for different, we're going to make sure we use a not equal to sign. That's called an inequation. So please make sure that when you see the word different, you're immediately thinking not equal to. So we know for this one that a is equal to 2, and b, we don't know what it is, but we know it can't be 3. Okay, let's actually do some SAT style questions now. So for this one, well, right away, we know the answer has to be 0, 1, or infinitely many. So 2 and 6 just kind of can't work. So we got kind of lucky with this one. Right away, we know those are wrong. We're going to, very first thing we're going to do is we're going to look at the slopes. So the slopes are 2 and 6. We see that those are not equal. So we're going to write 2 is not equal to 6. And if they're not equal, that means they're different. And different slopes, we don't even need to check the y-intercept. We know that those have one solution. So that means they have one point of intersection. So the answer is B. Great, let's keep going. Okay, so for this one, same kind of deal. I mean, 2 I can just cross off right away. That can't be that. The slopes are both 3. Those are equal, so we're going to write same slope. And the y-intercepts, those are both 5, so we're going to write 5 equals 5. And the y-intercepts, we have same y-intercepts, same slopes and same y-intercepts. If we look at our table, that tells us that we have infinitely many solutions. So the answer to this question is D. Great. Okay, so to make these a little bit harder, or a slightly different way this could be asked is they could, instead of giving it to you in a system, they could give it to you as an equation. But as you'll see, it's kind of the same idea. So what we're going to do is we're going to kind of hold up mx plus b above both sides of the equation and basically do the same thing. So the slopes are -5 and -5. Those are equal. So we have the same slope. And then we're going to identify the y-intercepts. The y-intercepts are 0 and 8, which are not equal. So we're going to write 0 is not equal to 8. And if they're not equal, that means they are different. So we have same slope, different y-intercepts. Don't get confused there, guys. If like a term is completely missing, the kind of number that's in hiding there is a 0. A missing constant is a 0. A missing coefficient is usually a 1 or a -1. We'll do some like that in a minute. So this one does have no solution, same slopes, different y-intercepts. So the answer is 0 solution. So we're going to pick D. Okay, great. And lastly, you'll sometimes see questions like this where before you can hold up mx plus b, you have to do some algebra. So this takes a lot of practice and a lot of, you have to be very comfortable with algebra, but oftentimes you have to just distribute or move a term. So for this one, we're going to distribute both sides. So 2 times 3x minus 9, 2 times 3x is 6x, minus 9 times 2 is -18, 6 times x is 6x, 6 times -3 is -18. So both sides are going to read 6x minus 18, 6x minus 18. Now we pick out the slopes, which are both 6. And now we're going to pick out the y-intercepts, which are both -18. So this one has the same slope and same y-intercept. That means it has infinitely many solutions. So the answer for this one is C. Great. Let's keep going. So the second skill is basically the same thing, but we're going to now use what we just learned to kind of do the opposite. They're gonna tell you which case it is, and we're gonna use that to find some sort of missing value. So for this one, they tell us it's no solution. So before I do anything, I'm writing that down on my scratch paper. Same slope, different y-intercept. Now I'm going to circle the slopes They are -8 and b. Because we have same slope, we know those are equal. So -8 equals b. And then you do algebra to, for this one, we would just do algebra to solve for b. We already have b by itself. We don't have to do anything. The answer is just -8. And we didn't even really need to use the different y-intercepts portion because that's not really going to help us find a value, right? Knowing what it's not equal to doesn't help us answer this particular question, but you probably will see questions once in a blue moon where that part is important. So maybe we'll do some like that at the end. We'll see. Great. Okay. So for this one, they tell us it has one solution. I'm noticing the left side is pretty good. He's in mx plus b form, but the right side isn't. So the first thing I'm going to do is distribute that 2. And we get 10x plus 5 equals 2kx plus 14. And because they told us it has one solution, these guys have different slopes. So we are going to circle the slopes. 10, and this is really important, guys. It's not 2. It's the slope is whatever's in front of x. So it's 2k. So different means not equal. So we're going to write 10 is not equal to 2k. Now, we need to solve for k, and if you didn't know this, you can actually do algebra on inequations just like you can on regular equations. So what we're going to do is to get k by itself, we're going to divide both sides by 2. And we get k is not equal to 5. So notice how the question says, which of the following could not be the value of k? The answer is 5. K cannot be equal to 5. Great. Let's keep going. Okay, this one's a lot more challenging. Really seems like neither side are quite in slope-intercept form. First thing I'm going to do is distribute that 4. So 4 times 2x plus 3b, that gives us 8x plus 12b when we distribute. And now the right side's actually looking pretty good. We have mx plus b. Think about it. 12, b is a constant, 12 is a constant times a constant gives you a constant. So 12b is good, 8x is good. The only thing is on this left side, we have 2 x's and we just want 1 x. So we could move the ax to the other side, but then it wouldn't really get absorbed into that 8x. So why don't we move the 3x to the other side? So we're going to add 3x to both sides, and we get ax plus 5a equals 8x plus 3x is 11x plus 12b. And now all of a sudden, this is looking really good. We have mx plus b equals mx plus b. Those 5a and 12b, those look kind of scary and confusing, but as we talked about, a constant times a constant is still just a constant. So try not to let that confuse you. Okay, so we know these guys are same slope, same y-intercept. So we are going to pick out the slopes, a and 11. So a is equal to 11. And now we're going to pick out the y-intercepts. So the y-intercepts are 5a and 12b. And they're the same, so we're going to set those equal. 5a equals 12b. And now we can take the a equals 11 and plug that in. And we get 55 equals 12b. And now to get b by itself, we're going to divide both sides by 12. And we get b equals 55 divided by 12, which is our answer. So that one was a lot more work. We had to distribute. We had to move a term over to another side to make it look like mx plus b. But once we did that, we were pretty much just doing the same thing as before, just making sure to really neatly show our work so that if there's 2 constants and we solve for a constant, if we neatly show our work, we can kind of insert it into that other part of our work without much stress. So try to keep this as neat and organized as possible, especially as these problems get pretty long. Okay, now the second most important slide on the entire thing is how to do this when we have standard form. So standard form of a line is ax plus by equals c. And if you have two of them, I like to call the second one dx plus ey equals f. It's just alphabetical order. It's nice and easy to remember. So when we have no solution, we know that a over d is equal to b over e, which is not equal to c over f. For one solution, a over d is not equal to b over e. And for infinitely many solutions, all three are equal. A over d equals b over e is equal to c over f. And you might think, well, Kyle, that's kind of hard to remember. So like one little trick, if you kind of think about the first set of equal signs or not equal to signs as the slope part, so like no solution has same slope, infinitely many solution has same slope, so there's equal signs there. And then the one solution we know is different slope, so we know to put a not equal to sign there. And then the second part, if there is a second part, is the y-intercept. So no solution is same slope, different y-intercept, so it's got an equal followed by a not equal. And then infinitely many has an same slope, same y-intercept, so it's two equals. So hopefully that kind of helps. Again, guys, this slide is really important, so please pause this video and write this down. You can figure this out on test day, but the reality is these questions can take a long time. So if you don't know this down pat going into the test, even if you can figure the question out, you're probably going to spend too much time on it, and that's going to detract from your score, and we don't want that. Okay, so let's do some basic problems. So we've got two here. I don't know how many solutions this has, so I'm going to identify all these constants. And I'm going to just write them down. So 4 divided by 2, 6 divided by 3, 8 divided by 4. Now I'm going to simplify. So we get 2, 2, and 2. And now I'm going to insert whether they're equal or not equal. So I put equal signs. So I got 2 equals 2 equals 2. And once they get harder, guys, don't be afraid to just do the simplifying on a calculator. Especially Desmos is really helpful with that. And I'm seeing, oh, this is looking a lot like this one, which tells us that from the table that it has infinitely many solutions. And similarly, you can do this to find constants as well. So let's say I tell you this one has no solution. I'm going to first write down what we know about no solution. A over d equals b over e is not equal to c over f. Then I'm going to identify, circle, put a rectangle around all those constants. And I'm going to put them into that relationship. So negative 3 divided by 6 equals 5 divided by b is not equal to 9 divided by negative 54. Now, I didn't really give you guys a question, but let's say we want to find b. We don't really care about what it's not equal to, so why don't we just use the kind of left half of this relationship? So I'll put a box around that. And now, once you get this, all you got to do is cross multiply. So we're going to cross multiply negative 3 times b, negative 3b. 6 times 5 is 30. So we get negative 3b equals 30. And then we do divide both sides by negative 3. And we should get b equals negative 10, which I believe is the answer for this one. So hopefully that kind of shows you the idea. Let's do a bunch of SAT style questions now. And I'm going to keep the information we need right at the top in our little table here. Okay, at how many points do the graphs of the equations intersect in the xy plane? So we're going to first write down, identify, can't be 2. We're going to identify all those constants, and then we're going to put them into our proportions. So 8 over 16, 3 over 9, 15 over 15. Now we're going to simplify all these. So we get 1/2, 1/3, and 1. I see that the first part, 1/2 and 1/3, is not equal to. So I can just stop there. It's already has to be one solution. Because remember, that first equal, not equal to sign is the slope, and one solution has to have different slopes. So the slopes are different, so it has one solution, so our answer is B. Great, let's do another one. Okay, very first thing I'm going to do is identify the constants. I'm going to write the proportions, negative 36 over 4, 9 over, the constant is missing, so that's kind of like, the coefficient is missing, so a missing coefficient is like a 1. So that in front of that y is like a negative 1. And then we do negative 13 over 117. We're now going to simplify all these. And we get negative 9, and negative 1/9. So we see that the first two, negative 9 and negative 9, are equal. But then that neither of those is equal to negative 1/9. So we write an equal to sign and then a not equal to sign. And all of a sudden, that is looking a lot like the no solution case. So this one has 0 points of intersection, no solution, 0 solutions. So we're going to pick answer choice A. That's it. Okay, now we're going to do the same thing, but with constants. So before you do this, just like when we did the problems with slope-intercept form, write down the information that you know on your scratch paper before you even start. So infinitely many solutions, before I even do anything, I'm writing down A over D equals B over E equals C over F. So I didn't put it in the work on the bottom, but you should be writing that down whenever you start one of these problems. Okay, now we're going to pick out our constants, and it's going to look something like this. 2 over 14 equals 3 over B equals 8 over 56. Now, if you want, you can simplify the left one and the right one before you continue, but it doesn't really matter. You have a calculator anyway, so it's not like the numbers being big is going to make it harder. So I would just remove less rooms for error and maybe not simplify it, but you can do whatever you want. I'm going to not simplify it. And I can set the 3 over b equal to either of those things to solve. Why not, just like we were doing before, why don't we just get in the habit of, if possible, doing the left side? Just because that would also work in a no solution problem. So it maybe makes sense to do it in a way that is applicable to more types of problems. So we're going to cross multiply. We get 2b equals 42. Divide both sides by 2, and we get b equals 21. Great. Okay, this one they tell us it has no solution. So what we are going to do is we are going to jot down, very first thing, A over D equals B over E is not equal to C over F. We're going to identify our constants, just circle them. And then we're going to put those into the relationship. So H over negative 22 equals 5 over negative 30, which is not equal to 19 over negative 4. For this one, knowing what it's not equal to doesn't really help us, so let's just kind of look at the left half. And we're going to cross multiply. We should get negative 30h equals negative 22 times 5, which is negative 110. And we divide both sides by negative 30. That should simplify to 11 over 3, which should be the answer for this one. Again, if you ever get messy fractions, just simplify it on the calculator. No reason not to. And of course, especially for these harder ones, you probably want to check your answer using Desmos. So just keep that in mind. That's always a good idea, especially on a student-produced response question where the answers aren't in front of you and kind of maybe the chances of making a mistake kind of go up. But we see when we plot this and we type in the answer that we get parallel lines, which we know is no solution. So it looks to be parallel, so we know we probably did it right. So every once in a while, you're going to see a problem that gives you a heart attack. You ought to know by now. You ought to know by now. Who needs a house out in Hackensack? Is that all you get for your money? When you see a problem like this, you need to stay calm. Take a deep breath. Remember your training. I'm going to help you make it so that these problems are not so scary. I want you to know it's gonna be all right. Don't you know it's gonna be all right? You say you got infinite solutions. Well, you know, we'd all love to see the plan. All right, enough of that. So this is the kind of question I'm talking about. And I don't really have a good name for it, so I'm just going to call it messy standard form. And essentially what you have to do is you have to do a bunch of steps to get this guy in standard form and then do everything we were doing before. And it's really tough because it's a lot of work, and they often make these questions student produced response, so you don't even have answer choices to look at that you can try. So let's go over the steps for these types of questions. So the very first thing is you're going to clear the denominators if there's any fractions. We'll talk about how to do that. If you want to learn more on how to do that, there's a plethora of videos on YouTube going over how to clear denominators. We're going to put both equations in standard form using algebra. You're kind of going to have to think on your feet a little bit. And step 3 is to just use the table, just like we did in skill number 4. So let's try working through this one. So the first step is we are going to clear the denominators, but fortunately for us on this one, there aren't any fractions, so we're kind of good there. We don't need to do anything. So now we're going to put both these equations in standard form. And let's do the top one first. So I'm kind of, remember guys, ax plus by equals c. So kind of everything is where it should be except for that 8x. So I'm going to move that 8x. We're going to move that whole thing as a unit. And to do that, we're going to subtract 8x from both sides. We can cross that guy out. And we should get negative 3x plus 6y equals negative 4. And if we hold that up to standard form, it looks a lot nicer. So I think we did a good job. Now let's do the other one. So pretty much everything is in its place except for that negative 3x on the right side. So we're going to add 3x to both sides. And that guy goes away, and we should get 10x plus hy equals 7, which now looks like it's in standard form, so we're all good. Now we can write the equations vertically on top of each other and do exactly what we were doing before. So if you guys remember on the previous slide, I said this one had no solution. So we're going to do a over d equals b over e is not equal to c over f. We are going to identify all the constants and put them in. Negative 3 over 10 equals 6 over h is not equal to negative 4 over 7. And again, we don't really care about what that not equal to part is. That's not really going to help us find h for this problem. Maybe we'd get another problem in the future where that's important. And we cross multiply, we get negative 3h equals 60. Divide both sides by negative 3, and we get h equals negative 20. And remember what I said, guys. We really want to use Desmos to check our answer. Don't type in the equations we came up with. Type the equations from the original question, exactly as it's written in the question. Then on the next line, type in your answer, and hopefully it looks the way you expect it to look. This was a no solution problem. We expect to see parallel lines. This graph is parallel lines, so we know we probably did it right. Great. Let's do one more. So in the given system of equations, p is a constant, system has no solution. Okay, this one's much messier. The first thing we have to do is clear the denominators. So like I said, go look up videos on YouTube if you want to practice this more. To clear denominators, what you're going to do is you're going to pick out all the denominators in an equation, and you're going to find the LCD, or least common multiple, of those denominators. So for this one, it's just 2 and 4. The LCM is just 4. I just know that. If you don't know that, or if the numbers are harder on your actual test, or trickier to figure out, there is an LCM, least common multiple function in Desmos. So I just typed in LCM 2, 4, and it told me it's 4. So once you have that LCM, or LCD, we're going to multiply the whole equation by that LCD. So we're going to multiply the whole equation by 4. And there's a lot of fraction math here. Again, if you're worried about making a mistake, don't be afraid to use a calculator as you go. So 4 times 3 halves, that's 6y. 4 times 2, that's 8x. 4 times 15 over 4, the 4's just cross out, we get 15. And then minus 12x. So it should be 6y plus 8x equals 15 minus 2x. And then for this other equation, this one's not so bad. The only denominator is 3. So we're just going to multiply the whole thing by 3. So all those 3's just go away. And the negative 1 becomes a negative 3 because negative 1 times 3 is negative 3. So we get 5x minus 3 equals py minus 10. And let's see. Now we're going to put them in standard form. And let's do the top one first. So that x on the right side shouldn't be there. So I'm going to add 12x to both sides. Cross that guy out. We get 6y plus 20x equals 15. Now I'm just going to use the commutative property of addition to switch the 6y and the 20x. So just make sure you do that very carefully and that everything has the sign it's supposed to. So we're going to rewrite that as 20x plus 6y equals 15. Looks good. Now we are going to do the other equation, and really the only thing, well, there's two things out of place here. That negative 3's got to go to the other side, so we should add 3 to both sides. And that y term should be on the other side, so we're going to subtract py from both sides. Cross that guy out, cross that guy out, and you should be left with 5x minus py equals negative 7. And hopefully that's standard form, which I think is good. And now we can just do everything we were doing before. So it was a no solution problem, so we're going to write a over d equals b over e not equal to c over f. Identify the constants, put them in. 20 over 5 equals 6 over negative p is not equal to 15 over negative 7. Don't care about the right side, and we're going to cross multiply. Negative 20p equals 30. We divide both sides by negative 20, and we get p equals negative 3 over 2. We are once again going to check our answer using Desmos. We're typing it in with all the fractions exactly as it's written in the original question. Then we're typing in our answer, and then we're looking at the picture on the right to see if it looks like what we expect it to look like. No solution, we know, forms parallel lines. Those are parallel lines, it seems. So we probably did a good job. We probably got it right. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And be on the lookout for a pinned comment with more helpful links about today's topic. Let's switch to the whiteboard for the final review. Okay, let's get started. For this one, slope-intercept form, so we're going to look at the slopes and the y-intercepts. So 6 does equal 6, so they have the same slope. And 3 is not equal to negative 8, so they have different y-intercepts. Same slope and different y-intercept means we have no solution from our table. So that means there's 0 points of intersection. So the answer for this one must be A. Since I don't have an answer key, let's check it really quickly using Desmos. 6x plus 3 and y equals 6x minus 8. Okay, those definitely give me, it seems to give me a system with no solution, so that looks good. Okay, let's move on to the second one. So these guys right away, they have, their slopes are not equal, so they have different slopes. As soon as we see different slopes, we know that we have one solution. So we're going to pick one point of intersection, which is answer choice B. And let's see, y equals negative 3x minus 12 equals negative 2x plus 4. If we plot that, you see that these ones do intersect at some point. So we do have one solution. That looks good. Okay, great. For this one, same deal. The slopes are both 8 and both 1. So it has the same slope and the same y-intercepts. So that tells us we have infinitely many solutions. So the answer for that one is D. You can already tell for slope-intercept form, if it looks the same, it's going to have infinitely many solutions. Ax plus 1 and ax plus 1 are exactly the same. Good. Okay, for this one, I'm going to have to distribute. So 9 times 3x, that's 27x. 9 times negative 6, that's minus 54. And then we get 27 times x, that's 27x. 27 times negative 2, that's negative 54. Once again, very similar to that one, last one, it looks like they have the same slope and the same y-intercept. So this guy should have infinitely many solutions. And you can just type in the equation, but it will probably make more sense if you split it up. So watch what I do. Y equals 9, 3x minus 6. And then y equals the right-hand side, 27 times x minus 2. And you see the blue perfectly replaces the red. So that means we have infinitely many solutions. Very good. Okay, this one, same kind of deal. We're going to pick out the slopes. And we have the same slope. Same slope. And then the y-intercepts are 3 and 0. So 3 is not equal to 0, so it has different y-intercepts. So this one has no solution. And that would mean there's 0 points of intersection. Let's graph it, see if we did it right. So we're going to do y equals 12x plus 3. And then y equals the right-hand side, 12x. And looks like these guys are parallel. They're not going to cross. So I think we did a good job. Let's go back over here. Okay, this one looks like a little bit more work. So we're going to distribute that 7. So we get negative 14x plus 35. And then also on the right-hand side, I'm going to use the commutative property to switch it. Just make sure you keep the signs what they are, right? So we're going to write 11 minus 6x as negative 6x. So negative 6x, positive 11. Okay, now I can check the slopes and y-intercepts. I don't even need to check the y-intercepts. I right away see that negative 14 is not equal to negative 6. So it has different slopes. So these guys are going to have one solution. So that is answer choice B. And let's do what we did last time and graph the original question to see if we did it right. So y equals 7, negative 2x plus 5. Y equals 11 minus 6x. And it does seem like these guys have one solution. They cross at one point. So it seems like we did a good job. Great, let's come back over here. Okay, so this one has no solution. So right away, I am going to just jot that down. So same slope, different y-intercepts. And the slopes are those guys, and the y-intercepts are those guys. So we have -9 equals 2b, and 2 different, not equal to -17. Okay, so everything seems to be in order here. We just have to solve the left equation, -9 equals 2b. So we're going to divide both sides by 2. And we should get -9 over 2 equals b. You could also put that as a decimal. Let's see if that is correct. So we're going to come over here. We're going to do y equals -9x plus 2. And then we're going to do y equals 2bx minus 17. And we're going to type in our answer, -9 over 2. And it certainly seems like these guys have no solution. They are parallel and they never cross. So it seems like we did a good job. Great, let's come back over here. Okay, this one has infinitely many solutions, so we're going to do same slope. Why don't I do that over here? So same slope and same y-intercept. Okay, so the slope is 10 and -5b. So 10 equals -5b. I divide both sides by -5, and I get b equals -2. That's important. Why don't we put a box around that? Now we're going to do the y-intercepts, which are 2b and 5c. So we're going to do same, 2b equals 5c. Now we're going to plug in the -2, so 2 times -2 equals 5c. 2 times -2 is -4. And now we divide both sides by 5, and we should get c is equal to -4/5. Let's go over here and see if that is correct. So we're going to type it in exactly as written, y equals 10x plus 2b. And then we're going to do y equals -5bx plus 5c. And then we're going to do b equals -2. And c equals -4/5. And it seems that the second line perfectly replaces the first, so that means it has infinitely many solutions, so we must have did a good job. Must have done a good job. Great, let's come back over here. Okay, so that right side is not in slope-intercept form, so we got to fix that. So kx plus 16. 8 times 4x is 32x. 8 times 2 is 16. Now we're going to one solution tells us different slopes, so we're going to pick out the slopes. And we say that k cannot be 32. So the y-intercepts are the same, but again, that doesn't really matter here because this is a one solution question. The y-intercepts could be the same or they could be different. Doesn't really matter that much for a one solution one, so don't worry about that. So let's check this one. It's going to be a little weird, but we can type in y equals kx plus 16, and we can type in y equals 8 4x plus 2, and we can type in Let's see what happens when k is 32. And let's make a... So when k is 32, it perfectly replaces each other. So it has infinitely many, which we don't want. We want one solution. But see, everywhere else, no matter what else I make k, if I make it anything else, it will intersect. So it can be anything except 32. Because 32 would result in infinitely many, which we don't want. Great. Okay, all right, I'm definitely going to have to distribute that left one. So that's negative 15x. Let me do that a little bit higher up. So negative 15x and then plus 40a equals negative ax plus 4x minus 20b. And now, really the only guy that's out of place is this 4x here. We could move the ax, but we want to move something with a number in front of it if possible so that it can kind of get absorbed into that negative 15. So we're going to subtract 4x from both sides. Let's do that. This guy goes away. And we are left with negative 19x plus 40a equals negative ax minus 20b. So, no solution has the same slope and different y-intercept. So the slopes are the same. So negative 19 equals negative a. So that means a is equal to 19. So right away, this one's looking good. And now we're going to do different y-intercepts. So 40a and negative 20b. And different, so we're going to set them not equal. So 40a is not equal to negative 20b. Okay, now we're going to plug in the 19. So that gives us 40 times 19 is not equal to negative 20b. And 40 times 19 is 760, I think. Let me see. I'm just going to do this all on a calculator. 40 times 19 is 760. Divide by negative 20, and we get b is not equal to negative 38. That should be correct. So this one is looking right. And so it's going to be 1 and 3. So that is answer choice D. So now to check that, why don't we just type it in? So y equals 5 negative 3x plus 8a. Hopefully I did that right. And y equals negative ax plus 4x minus 20b. And we're going to do a equals 19. And b cannot be equal to negative 38. What happens when we get... so when we have b is equal to negative 38, we get infinitely many, but we don't want infinitely many because this is a no solution question. You see, if we move the slider, see how it's kind of just moving away? Oh, that means we did a good job. So this would give us no solution. So just anything besides negative 38 is valid. All right, great. Let's go back over here. Okay, so now we got to do the standard form ones. How many more? Just a couple more left. All right. We're going to do 7 over 14, 13 over 26, 20 over 28. We're going to simplify all of them. So 1/2, 1/2. Those guys are equal, so we got to check the y-intercepts. 20 over 28, that's 5 over 7, something like that. Yep. 5 over 7 is not equal to those other guys, so we're going to put a not equal to sign. And this is looking a lot like A over D equals B over E, which is not equal to C over F. So the answer must be no solution, so 0. Let's check it. So we're going to type in 7x plus 13y equals 20. And we're going to type in 14x plus 26y equals 28. And these certainly look like they have no solution. They are parallel. Very good. Let's go back over here. Okay, same deal for this one. We're going to just be really careful to, get those constants correct. So -5 over 15, 1 over -3, 17 over -51. And I think that is all -1/3. So they're all equal. So this one is A over D equals B over E equals C over F, which is infinitely many. So this one is answer choice D. Great. Let's check it. So -5x plus y equals 17. And 15x minus 3y equals -51. And I typed something in wrong. Here we go, 17. Good, okay, so the blue perfectly replaces the red, so that means we have infinitely many solutions. Okay, great, just a couple more. Okay, no solution, so that's A over D equals B over E is not equal to C over F. And we're going to just be very careful picking out those constants. Always include the sign. And we're going to put that in. So we're going to do -10 over 25 equals -5 over B, which is not equal to 23 over -4. We don't really care about this one because we're trying to find B. So we're going to just look at this guy, and we are going to cross multiply. So we get -10b equals -5 times 25. That's -125. Then we divide both sides by -10. And we should get 25 over 2. So let's see if that's right. -10x minus 5y equals 23. 25x plus by equals -4. And now we're going to put b equals 25 over 2. And the question told us it has no solution. These guys are definitely parallel. So it seems like we did a good job. Stupendous. Let's clear this. Let's go back over here. We are almost done. Okay, so for this first one, we're going to do 8x minus 12y plus 5 equals 17 minus 3y. There's two guys that are kind of not where they're supposed to be. This one and this one. So we got to move both those. So we're going to add 3y to both sides. That guy goes away. And then we're going to subtract 5 from both sides. That guy goes away. And we get 8x minus 9y equals 12. And now we're going to do the other one. And that is, first, what we're going to do is we have a denominator of 2. So we're going to multiply the whole equation by the least common denominator, which is just 2. So we should get negative 52x plus 63y equals negative 14p and then plus 4x. I'll just put this over here. Okay, so now we're going to, those x and y's look pretty good. We just need to subtract 4x on both sides. So we should get negative 56x plus 63y equals negative 14p, and that looks really good. So why don't we just rewrite those vertically now? So 8x minus 9y equals 12. Negative 56x. Oh, I don't know how that happened. Plus 63y equals negative 14p. And we're going to set up our proportion. So 8 over negative 56 equals negative 9 over 63 equals, because it's infinitely many, so this is same slope and same y-intercept, 12 over negative 14p. So now I can solve this using whichever one. And you might want to simplify these first, but why don't I just use the one on the right just because it's already next to it. So I'm going to do negative 9 times negative 14. That gives me 126p. And then 12 times 63, hopefully I didn't make a mistake anywhere, is 756. Divide both sides by 126. And I get p is equal to 6. Great. Wow, let's see if that's right. Let's go back and type this in over here. So 8x minus 12y plus 5 equals 17. Always use the original equation from the question. No reason not to. Negative 26x plus 63 over 2 y equals negative 7p plus 2x. And we said p was 6. And it has infinitely many solutions. Let's see if that's right. Yep, the blue perfectly replaces the red. So it seems like we did a good job. Okay, let's go back over here. I believe there's one more question. Question 15. Okay, so we got to clear denominators on both of these. For this one, the only denominator is 7. So we're just going to multiply the whole thing by 7. For this one, we've got 12, 4, 2, and 3. Pretty sure it's just 12. But in case you're not seeing that, don't be afraid to use Desmos to help you out a little bit. So the least common multiple of 12, 4, 2, and 3 is 12. So we're going to multiply that whole top one by 12. And again, if any of the fraction math is confusing you, don't be afraid to just use your calculator to help you out. So we're going to do 12 times 5 12, so that's 5x. And then 3 times 9 is 27y. 6 times 9 is 54. 4x. And why don't we just do all the work for this one right now? So we're going to add 4x to both sides. And we get 9x plus 27y equals 54. Hopefully I did that right. And let's just do the second one down here. So 7 times that whole thing, that's negative 24x plus 35 equals 7py minus 222. And we need to move the 7py, and we need to move the 35. So we're going to subtract 7py from both sides. Cross that guy out. And we're going to subtract 35 from both sides. So we should get negative 24. Oh, cross this guy out. So we should get negative 24x minus 7py equals, I don't know what negative 222 minus 35 is. Negative 257, I think. So that's our second equation. So now I kind of already nicely wrote them vertically, but this one has no solution. So we're going to do a over d equals b over e is not equal to c over f. So we're going to do 9 over negative 24 is equal to 27 over negative 7p, which is not equal to 54 over negative 257. And you see, guys, I'm just getting that from here. And we're trying to find p, so we don't really care about this. So we're going to cross multiply and divide just with this one like we were doing before. So why don't we come over here and do that? So 9 times negative 7p, that's negative 63p. And that's equal to negative 648. I'm going to divide by both sides by negative 63. And I should get p is equal to 72 over 7. And I'm just going to really, really hope that that is correct so I don't have to do this again. Okay, let's go back over here. Type in the original equation exactly as written. Good. And this other one is negative 24/7 x plus 5 equals py minus 222 over 7. And we're going to make p, what did we say, 72 over 7. So let's try that. Very good. Looks good. Okay, so we said for this one we wanted no solution, and seems like if we zoom in and zoom out, they don't cross at any point. So it seems like we did a good job. All right, very good. That was the last question. Let's go back to the slides. All right, thank you so much for watching, everybody. I worked really, really hard on this video, so please comment below your thoughts. I'm really curious to hear if this video and worksheet helped you. Don't forget to like this video and subscribe for more digital SAT math content. And if you need tutoring, please check out my information in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.